Recent advances in microprocessor architecture and algorithm design have made it possible to deploy machine learning workloads on even the smallest of microcontrollers. And this led to the concept of TinyML or tiny machine learning. If you're going to look at the field of TinyML, one first thing you're going to ask yourself is what is machine learning? And that'll be the first thing we're going to be looking about. Machine learning is simply a subset of artificial intelligence that deals with development of algorithms and models that are deployed on computer. These models and algorithms enables the computer to learn and make predictions based on data. So carrying all this and putting it into a tiny computer, we have the concept of TinyML or tiny machine learning. Therefore, if you are to define TinyML, we can simply say that TinyML involves running machine learning algorithms on low power microcontrollers or even any other resource constrained devices. So with this, we have access to running real-time and low latency on edge devices without relying on internet connectivity. One basic example is our mobile phones. Most of our mobile phones now are equipped with some kind of artificial intelligence functionality that enables them to run all this AI algorithm on the edge without having to connect to the internet. So this is a possibility that TinyML brought to us. So with the recent advancement in TinyML, we have seen improvement in healthcare, in smart homes, in agriculture, and also in wearables. Why should you even care about TinyML at all? Or what are the advantages of tiny machine learning? There are a lot of advantages that we can get from TinyML, but I'm going to summarize it using an acronym that was put forward by Jeff Bear, which is BLERP. The B stands for bandwidth, meaning that with TinyML, we have access to some data that might not have been easy if you are going to rely on normal computers or other form of GPU computers due to low bandwidth. Also, the L stands for latency. It's much more easier for us to transmit and communicate in the device instead of having to rely on internet connectivity. An example of this is an autonomous vehicle. It is much more easier for them to run the AI on the edge, that is on the vehicle, than if they have to connect to the internet before they can run the basic machine learning workload that the vehicle has to run. The E stands for economics. It's much more easier and cost-effective to build those tiny computers than having to build big computers or having to send those data over the internet. The R stands for reliability, which is it's much more reliable if you have to process the artificial intelligence on the edge than having to send it to the network where it might get compromised or you might have a bad response. Also, the P, which is the last part, stands for privacy. If you don't have to send the user's data outside of the device, it's much more private to the user, and then any AI or ML can run on the edge without transferring the user data from one place to the other. With all this, we can say therefore that TinyML finds application where we have devices that are battery powered, devices that are in remote environments, or even when we are looking at our wearables or our mobile phones. It is also worth noting that unlike our other computers, our GPU computers or our normal CPU computers, there are basic challenges that TinyML has. So it has low processing power. The devices are constrained. We can't always do whatever we want to do, and then the energy is also constrained. These are the basic challenges that TinyML brings for us. So if you're an hobbyist, you're a student, you're a developer, you're an engineer, or just anyone that wants to learn more about tiny machine learning or want to learn how machine learning can be embedded into embedded devices, this tutorial series is exactly for you. So I'll just run quickly before we round off this introduction on the tools that you're going to be using throughout this series. So I will look at the hardware and also the software. From the software angle now, we're going to be using the Arduino IDE, maybe the mobile editor, that's the web editor, or the desktop version, any one of the two is going to work. We are going to be using the Edge Impulse platform. We are going to be using the Keil Studio. We use the Google Laboratory, and you also have to download Python 3.6 on your laptop. If you're not familiar with any of this, don't worry. Once you are in that process, I'm going to be walking you through how to set them up. Also, regarding the software part, we're going to need your laptop. It might be a desktop or a laptop. You're going to need some other microprocessor board also. I'm going to be using Arduino Nano RP2040. It's a very tiny board. And also, sometimes I'm going to be using the Edge Impulse kit. This was given to my university as part of the Edge Impulse training program. And here I have Arduino Nano 33D license. So I'm going to be using this also. So if you don't have any of this, don't worry. I'm also going to be walking you through how to use some virtual hardware from HAM or from other platforms. So I'm going to be walking you through how to set all these devices up if you're just working with them for the first time. So any materials or any resources that you are going to be using, I'm going to be putting them in the description below. So you can always click on it to learn further on TinyML. If you find this tutorial helpful, don't forget to like, share, and subscribe. And if you have any suggestion on any topic that you want me to cover, or you have any questions regarding the topics that we're going to be covering, feel free to drop a comment in the comment section, and I'm going to get back to you as early as possible. So that's basically all as for introduction to tiny machine learning, and we're going to get started once and look at different aspects of tiny machine learning. So let's get started.